Exercise A-4, Perimeter of Composite Shapes. 1. Determine the perimeter of each composite figure. Show your work. Remember, perimeter means the outside border of any shape. So in this diagram, we have 3 sides with 1 tick labeled. So each of these 3 sides are 4 centimeters long. And 2 sides with double tick, so these 2 sides are 6 centimeters long. To calculate the perimeter, you multiply 6 by 2 plus 4 by 3. It becomes 12 plus 12, or 24 centimeters. In the second diagram, when you look at the outside border, there are 1, 2, 3, 4 sides of 4 centimeters and 1 side of 6 centimeters. To calculate the perimeter, you add 6 plus 4 times 4, which is 16, to get the perimeter of 22 centimeters. C. Here we have a 4-sided shape. It's a trapezoid. I know the bottom side is 5 centimeters. Here we have 11 centimeters and 23 centimeters. What I do not know is that the hypotenuse of a right triangle is missing, or the 4th length of this outside border is missing. So we can use the Pythagorean theorem to help us calculate the length of the missing side of this trapezoid. How long are the 2 legs in this right angle triangle? You can either draw a line inside the shape to figure it out, or you can extend to look at the other half of the right triangle. So here, the height of the triangle is 11 centimeters, and the base is 23 take away 5 centimeters, which is 18 centimeters. Using the Pythagorean theorem, c squared is equal to 11 squared plus 18 squared. That simplifies to 445. Now to calculate c, remember you need to take the square root of 445. So c is 21.1 centimeters. Now we have the lengths of all 4 sides of the trapezoid. We can add them all together. 23 plus 11 plus 5 plus 21.1. This is the perimeter of the trapezoid, 60.1 centimeters. Number 2. A circular fish pond is set in a rectangular patio. A. Plastic edging is placed around the pond and the patio. What length of edging is used? So here, if you take a look at the diagram, we need to put plastic edging around the circle and also around this rectangular shape. We need the dimensions of the rectangles, so we have those. Length is 12 meters and the width is 8 meters. To calculate the circumference or the perimeter of the circle, we can use the formula pi times the diameter. How long is the diameter of the circle? Using the given information, I know from top to bottom that's 8 meters. So I have 2 meters in and 2 meters in on the other side. So 8 take away 2 leaves 4 meters as the diameter. So here, circumference, the formula is pi d. So pi times 4, we get 12.6 meters. For the borders around the rectangle, we have to add the length and width, 12 plus 8, and double that. So times 2, that's 40 meters. Altogether, the amount of edging that we need is 12.6 plus 40, which equals 52.6 meters. Part 2. The edging costs $4.79 per meter. What is the total cost of the edging? Because this is the price of 1 meter and we need a total of 52.6 meters of edging, you multiply the price by the amount of edging that you need. So the edging will cost $251.95. Part B. The patio is paved with sandstone tiles. So now we're going to tile this entire patio area. What is the area that is paved? Remember, the circle represents a swimming pool or fish pond. So we do not need any tiles for the fish pond. So that means we need to find out the area of the patio, a rectangular patio, without the circle. Now, having our plan set out, we can say that the area of the rectangle is 12 times 8, length times width. And then we take away the area of a circle, knowing that the diameter is 4 meters. The radius must be half of that, which is 2 meters. So circle is pi times r squared, or pi times 2 squared. So we have 96 minus 12.6. It works out to 83.4 square meters. And the area to be paved is therefore 83.4 square meters. Part 2. Sandstone cost $45 per square meters. What is the total cost of the sandstone? So now, very similar to the edging question, we multiply the unit price, $45, by the amount of tiles that we need, 83.4 square meters, which works out to a total cost of sandstone of $3,753. Question 3. During gym, Ahmad walked around the playing field twice. So twice means 2 times. How far did he walk to the nearest meter? So where is he walking exactly? He is walking around just this side, here, 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 and here. So 1, 2, 3, 4, 5, 6 sides. Do we know the lengths of all 6 sides around the field? We know anything marked with the double ticks are 120 meters, so they're this side, the top side, and the right side. We know 200 meters at the bottom, but we are missing these 2 diagonal sides or slanted sides. So why don't we call them C for now? We notice that we are also told that the height of the top trapezoid in this diagram is also 120 meters tall. So if we use a little bit of imagination, here is a right triangle with C as the hypotenuse, height of 120, and the base, let's call the base A. And we can work out the length of A because we know from end to end this is 200 meters. So I have A plus 120 plus A equals 200. So 2A must equal to 80, or A must equal to half of 80, which is 40 meters. So now we know all the dimensions of the right triangle. We can set up an equation using the Pythagorean theorem. So C squared is 40 squared plus 120 squared. Solving for C, we get 126.5 meters. So in summary, if we look at the playing field, there are 3 sides of 120 meters long, 2 sides of C, which is 126.5 meters long, and 1 side of 200 meters. So if we do this calculation, we have 360 plus 200 plus 253, which is 813 meters. But don't forget, Ahmad is actually walking around the field 2 times. So we need to double this perimeter of the field. So 813 times 2 is equal to the total distance that Ahmed walked, which is 1,626 meters. Number 4. Cynthia will place strands of LED lights around her window. Each strand is 2 meters long. How many strands of lights does she need? Well, because we're dealing with lengths, we know we need to know something about perimeters. Now take a look at the diagram. Where are the LED lights to be placed? We can see that all the frames of 1.5 meters here, 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 here. So there are 4 sides of 1.5 meters, and then 2 meters here, 2 meters at the top. So 2 sides of 2 meters, and then the semicircle at the top. So other than the semicircle, we know the exact length of those straight sides. So let's calculate the length of the semi-circumference. So knowing that pi d is the formula to calculate circumference, for a semicircle, we have to divide pi d by 2. We are given that the diameter of the semicircle is 1 meter. So here we have pi times 1 divided by 2, which is 1.57 meters. So the total length of LED lights that we need will include 4 sides of 1.5 meters, 4 times 1.5, plus 2 sides of 2 meters, 2 times 2, plus the semicircle, 1.57. Add these up, it is 11.57 meters. For the number of strands of LEDs, you will have to divide the total length, 11.57 meters, by the length of each strand, which is 2 meters. It works out to 5.8 meters, or not meter but strands, so ignore the meter here. But we cannot purchase 5.8 strands of LED lights, so we need to round it up to 6 strands. Number 5 is a multiple choice question. Which pair of shapes can be joined with a common side to create a composite shape that has a perimeter greater than 25 centimeters? So if you try to combine these shapes in the way they're ordered, so combine shapes 1 and 2 together, 2 and 4 together, 2 and 3, 3 and 4, and so on, you will actually notice it is possible to come up with a perimeter greater than 25 centimeters in both scenario A and B. So you can select both as the correct answer.